Hello and a very warm welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here. Today we'll be talking about the Sikkim flash floods which took place recently. We'll be focusing majorly on the mapping portion, while also taking care to learn about the river systems, glacier systems, the lake systems, and all geographical formations that were responsible for the causation of this event. Let's start from the very basics. So as you can see in the map, this is the Ganga Brahmaputra basin. So here you can see the Ganga river. It originates from the Gangotri glacier in the Uttarakhand. And this is located in the western Himalayas, in the Uttarkashi district. So this river Ganga flows through the northern India, ends up in the Bangladesh as Padma river, which finally flows into the Bay of Bengal. On the eastern end, however, there is river Brahmaputra, or which is known as Yarlung Zangpo in the Tibet region in China. So this river, the Brahmaputra, it originates from a similar glacier known as the Chimayongdung glacier or Kimayongdung glacier from the Kailash range. This flows towards the east, enters India from Arunachal Pradesh, and in India it is known as Brahmaputra river. It has many supporting rivers or tributaries: Subansari, Teesta. Teesta is a river we are going to talk about in this lecture. It is located in the Indian state of Sikkim. So all of these rivers eventually go into the Bangladesh, whether it is Ganga or Brahmaputra. I'll clear this out for you. So Ganga is known as the Padma in Bangladesh, and Brahmaputra is known as the Jamuna. The Padma Jamuna river, both of them, mix into the Meghna river, which is the major river of Bangladesh, and eventually fall into the Bay of Bengal. So this is the river system that we needed to know. So we know now that Teesta is a direct tributary to the Brahmaputra, is located in the Indian state of West Bengal, Sikkim, as well as West Bengal, but majorly in Sikkim. So this is the river that got affected during this flash flood. We'll also see what happened to it. So let's move forward. So here you can see the Chimayongdung glacier, which is the origin of the Yarlung Sangpo or the Brahmaputra river. These are some territories: Dibang and Lohit, the Subansari, the Brahmaputra, this is the major river, the Kapili, Manas is in Assam, and the Teesta, which is in Sikkim. Alright, so let's move forward. This river becomes Padma. Here on the Gangas becomes Padma, and the Brahmaputra becomes Jamuna. They mix into the Meghna river and finally fall into the Bay of Bengal through the Bangladesh. This is the Hooghly river in the West Bengal region of India. So this is the related river system we needed to know before moving forward with the lecture. Alright. So just some facts about the Teesta river. The length is around 400 kilometers and the origin is Ponhiri mountain in the eastern Himalayas. These are some facts which will be very helpful for you in the prelims if a question is asked. And these are the notes which you should keep adding in the river systems, such as Teesta river system. Alright, eventually what happens when we keep making notes? Just a second. Then we have notes for everything and it is in our revision system, in the mental revision system. So we have answers to most of the questions. Alright. So it flows through two countries, which are India and Bangladesh, and it is also a cause of dispute between these two countries, the water disputes. Indian states, it originates in the Sikkim and flows through West Bengal to the Bangladesh, so it covers two states. Major Indian districts you need not know, but if you are around this region, then you can see the Darjeeling is covered here, and Cooch Behar is also covered. The confluence is important here, so it joins the Brahmaputra river at Phulchari Upzila in Bangladesh. So this can be asked as a statement that the Teesta rivers joins the Brahmaputra in India or Bangladesh. So it joins in the Bangladesh. All right. Okay, let's move forward. So its significance is that it is the largest river in Sikkim and second largest river in the West Bengal after the Gangas. All right. So this is the region, the Punhuri mountain, which serves as the origin of this river, Teesta. This you can see here is the state of Sikkim. So it originates from the eastern end of Sikkim, northeastern end of Sikkim, and runs down. This is the capital of Sikkim, Gangtok. Darjeeling is a major town here, where a scenic hill station. All right, let's move forward. So here we can see the site of the flood in this map. So this cloud burst over the South Lonak Lake. So as you can see, the Sikkim, we saw that the Teesta river system is here and it flows downward. Okay, so this is the Teesta river, but it originates from the eastern end. Now we are talking about the Lonak river, which is in the western end. And this is the Lonak lake here, from where the flash floods originated. Alright, so water released from the Chungthang dam. This is the dam here. And army personnel missing from Bardang and so on. So the flash flood originated from here and caused a havoc in the Teesta river system. So here is the map for that. Let us move forward for some other things. That this is the cloudburst location. We'll see later in the lecture that it was not the cause of the flood was not a cloudburst, but it was a glacier recession. And it has been a common theme in the 2023. So it is very much expected to be asked in 2024. We have a separate lecture for that also. I'll do the link. These all notes which I teach here in the lecture are always uploaded to the Telegram channel. So you can watch them here and add them to your personal notes. Our Telegram channel is Sarat Chandra IAS Academy. There are various quizzes as well as daily current affair notes being uploaded on the channel, so you can read them there. Well, let's move forward. So flash floods in Lachen in the Teesta river. This all we have seen. The origin of the Teesta river is here. And the Chungtham dam. This is the dam that was completely destroyed. The water gathers speed because of the slope. Because of the high slope. And this is Gangtok here. Let us see one more thing. This Lonak Lake river system. In the upper side, I have shown here the earthquake zones. So there was an earthquake on the same day in the Nepal that could have triggered this outburst. We'll see about that. Alright, let's see first the South Lonak Glacier Lake system. So it's in here. As we have already seen when we see the Sikkim. So this we are talking about the western end. This portion where South Lonak Glacier Lake system is there. In the image you can see these are the glaciers. As I have already told you, glaciers are the mountains formed out of complete ice or snow. Alright, and these are the avalanche source zones. Avalanche means a large flow of the ice in this system. These are the floating ice sediments here, and this is the lake made out of the floating ice sediments. This is the flow path of the lake, and these are the moraines. We'll see what is a moraine. This is the terminal moraines. Alright, so we'll see these. Let's move forward. So South Lonak Lake is a glacial moraine dammed lake. Alright, in India we sometimes call them moraine. So located in Sikkim's northwest region, and it is one of the fastest expanding lakes in Sikkim Himalayan region. But the expansion is not towards forward but towards backward. Initially it was like this, then the glacier receded backwards and it has expanded more and more. So in one of the 14 potentially dangerous lakes susceptible to the glacial lake outburst flood. So this is what happened, GLOF. We'll see this. So the lake is located at 5,200 meter above sea level, and it's formed due to the melting of the Lonak glacier. Let us see what is a moraine dammed lake. So a moraine dammed lake occurs when the terminal moraine has prevented some meltwater from the glacier from leaving the valley. So let's say this is the glacier and this is the valley and this is the lake. So some moraine is there to prevent the outflow. It is most common shape of that of a long ribbon. Example of moraine dammed lake includes Argentina, Chile. So there are some examples here. In the Shaurolpa you can see, or the Lona Creek here. Alright. So this is the glacier, this is the lake, and these are the moraine. This is natural outlet. It is formed because of the recession of the glacier itself. Let's say this is the glacier, this is lake here, this is lake here. So these are the moraines here. So a moraine geographically is a material left behind by a moving glacier. So let's say glacier is itself moving backwards or receding. Alright, so it leaves out some material that is known as the moraine. And then there is a lake formed here. This moraine will stop this lake from flowing outside. So this material is usually soft soil and rock, just as rivers carry along all sort of debris that eventually builds up to form deltas. Glaciers transport all sort of dirt and boulders that build up to form moraines. So it's sort of delta. Okay, here you can see the moraine structure. This is the rock and silt. This is a glacier's flow, let's say. This is a glacier. This is its flow. Then this is terminal moraine. This is bed load, medial moraine. You can see various different structures here. Let's see now about specifically the Sikkim floods. So we'll see what are the glacial lake outburst floods and how do infrastructure projects like the Chungtham Dam. So we have already seen this in the Teesta River system. It is located here in the middle, upon upside of the north of the Gangtok. So this dam, how it got affected, and it is at a height of 5,200 meters. So it's more than around 70% height of the Everest, we can say. So can such events be predicted and prevented? We'll see this also. Let's quickly go through this lecture. So more than 25 people have been confirmed dead and many more are missing from a massive flood that resulted from a glacial lake outburst in Sikkim in early hours of October 4. The voluminous outflow has destroyed the Chungtham Dam, which is critical to the Teesta 3 and Teesta 5 hydropower projects, and rendered several hydropower projects along the river dysfunctional. So basically when the river is flowing, there is hydropower project toward this side, north to south. But due to the high flow, the projects are now destroyed. So Chungtham Dam has taken much of the loss. Let us see what are glacier lake outbursts. So technically called a glacier lake outburst flood, these are instances of large lakes formed from the melting of glaciers, suddenly breaking free of their moraine. So we have already seen what is moraine. Natural dams that are formed from rocks, sediments and other debris. The South Lona Glacier located in North Sikkim, we have already seen this. This is let's say an article from the news. So I have already discussed everything that we need to know, and which is not a common knowledge, let's say. When I talk about this, this is the correct method of news reading. So this we will be seeing, but already we have seen what are glaciers. We have already seen what is moraine. We have already seen this Chungthang Dam. We have already seen where is North Sikkim. We have already seen where is Teesta located. We have already seen where is Lona or Lona Lake located. Alright, Lona Glacier. The glacier receded nearly 2 kilometers in 46 years, from 62 to 2008, and it further retreated by 400 meters till 2019. So there is an estimate 7,500 glaciers in the Himalayas, and GLOF has been associated with major disasters through the years. So is it a common disaster, can we say? Let's see. So similar disasters have been in the Kinnaur Valley floods in Himachal Pradesh and Kedarnath outburst in examples in the 2013. So among the Himalayan states in India, Sikkim has about 80 glaciers, more than any other state. So this can also be termed as a fact, which state has most glaciers. So it's not Uttarakhand, it is Sikkim. So over the years, climatologists have warned they could be responsible for lake outbursts. So it's a simple phenomenon. Glacier recedes, a lake is formed. When the moraine breaks, then there is a GLOF. So what triggered the Sikkim GLOF event? So there is uncertainty on this point. Satellite images from the National Remote Sensing Center, that of ISRO, suggest around 105 hectare, 1 square kilometer of the glacial flat lake has been drained out. This was on comparing images taken on September 28. So this all is just data. It essentially shows that a large portion of the lake was drained out. So this could have been from the more recession of glacier or glacier melting, that the moraines exceeded their limit that they could hold, and it got into an outburst. Alright. So water was nearly 60 feet above the maximum levels and gushed at nearly 55 kmph. So that's a lot of speed. So this is at very least thousands of cubic meters of water in a short time, and being midnight gave very little time for people downstream to react. So this is the, let's say, extent we can see of the GLOF, and this is the set of disasters that it can cause. What we need to know here for disaster management is that the sort of disaster it is, let's say GLOF, the reasons, the triggering events, and the extent of disaster it can cause. So that is one of the reasons why we need to learn about this. So NDMA, National Disaster Management Agency, reported that the primary reasons for the sudden surge appears to be likely combination of excess rainfall and GLOF event. The lake has a height of 5,200 meters with a towering ice-capped feature at about 6,800 meters in the north of it and in close proximity to the lake. So there is a speculation a heavy rainfall might have tipped the moraine to collapse and trigger the flood, but meteorological records don't reveal any evidence of such heavy rain. So this can be a very natural phenomenon also. There was also a series of earthquakes in Nepal. So this could have been as well the, let's say, reason. And tremors were felt till the Delhi National Capital region. So the inaccessibility of terrain makes ground observations that provide conclusive proof difficult. Let us see what was the resulting damage. So destruction of the Chungthang Dam. So we have already seen the Teesta River origin and the Chungthang Dam that lies here in the north of Gangtok. This glacier and river outburst. So this was the Chungthang Dam that has collapsed, and it was also a helpful dam in the Teesta River project, Teesta hydropower project. So dam is insignificantly damaged, and the quantity of slit and water present make it difficult to estimate the extent of damage right now. So all bridges downstream to the Teesta 5 hydropower station were submerged or washed out, disrupting the communication. Dams and hydropower projects in downstream West Bengal were not significantly affected, but were kept shut from heavy situation that resulted from the floodwaters. The state government has set up 26 relief camps in the 4 affected districts. The Sikkim State Disaster Management Authority, SSDMA, said on Thursday with at least 1025 people taking shelter in the 8 relief camps in Gangtok district. So this is the capital district. It has been significantly affected due to this GLF event. So how we can better prepare for these events, and can these be predicted, becomes a major theme. So several studies have warned over the years. One thing that you must remember and notice is that India as a country is a disaster resilient mode country. That means the resilience is our primary goal, not the disaster prevention itself. Okay, so we are focusing on that when the disaster happens, we must be well prepared for it, and we must have all the resources to act accordingly. Alright. So both the frequency and severity of such events is going to increase exponentially in the future because of what? Climate change. The Himalayan ecosystem is the most fragile in the world, and any disruption in the way we are managing these resources will have a problematic outcome for the people in the region. And one of the major causes, rising temperature, are leading to a wetter future and contributing to the climate change led extreme events. But it is also disturbing the fragility of the Himalayan ecosystem through hydropower and other dams. So specifically GLF, it is an outcome of warming of the region, first of all, and had been a major risk for the region. Once it is formed, you never know what trigger its outburst. So this is a very important information about this sort of disaster. So while the Teesta River is a source of hydropower generation for several power projects, the risk of GLOF-like events require greater care in planning and executing dam and other infrastructure projects, which account for the huge amount of water that can potentially gush through the mountains. As you already saw, it was more like 55 kmph plus speed, so that's a lot of speed. Early warning systems are implementable but require a coordination approach, such as multiple agencies promptly sharing satellite images that are trained towards the Himalayas and a network of sensors to provide adequate warning. So what we saw and learned from this lecture, I'll tell you very quickly, is always start with the mapping. If you don't read a mapping of any news, then it quickly becomes very incomprehensible as to what we are reading. If you are not focused on mapping, you will never know what the Himalayan system looks like. Where is the Western Himalaya, where is the Eastern Himalaya, where is the Sikkim, Where is this glacier located? Does the Sikkim have the highest number of glaciers? Why Teesta River is different from this system, and where the Teesta River is coming from, where it's going. All right, and where is the Chungtham Dam? Where is the Gangtok? Why the Gangtok got affected? Why the West Bengal did not get affected so much? All right, and what could have been worse in this situation? Which is the primary site for such events? All right, and what are the disturbances that are causing such events, such as, like, let's say, earthquakes? Okay, this is a delayed trigger event, such as it is formed once because of the rising temperature. The lake river water rises, and the moraines break because of something else, some other trigger event. So you know now what are moraines, what is the lake system, where is this located, and all. So this is how to read the news, and you can make better notes accordingly. I'll upload these lecture notes to the channel as well. So that's it for today. This is Yatharth here. Thank you very much. Keep studying and have a very good day ahead.